Well, folks, I hope you enjoyed the video about driving cars around stuck in traffic. I'm sure everybody here is familiar with the frustration of sitting in traffic. I'm going to tell a little bit of a story today with Josh Westerhold from Nissan and Jonathan Sprinkle, my colleague here at Vanderbilt, about what we can do to use automated vehicle technologies to make traffic better for everyone. We got this project started with grant funding from the US Department of Energy and the National Science Foundation, and we were promised to only do 3 impossible things. We, one, had to invent AI algorithms to control cars on the freeway that could make traffic jams less severe for everybody on the roadway, find 100 cars to deploy on the freeway, and then find a way to build a scientific instrument that could measure the impact in a meaningful way. So we're going to talk a little bit about how we overcame some of those challenges, and maybe Josh, to get us kicked off, you want to tell us a little bit about what you were thinking when we called you and said, we got an idea, and it's only going to cost you 100 vehicles. What do you think?
Yeah, I think the original thought was, well, of course, that's cool. Why not do that? You know, I've driven down I-24, and it's a monster. I hate driving down I-24, and there's a lot of interstates I've driven down, and I don't understand why this keeps happening. And so, you know, my immediate thought was, we absolutely should do this. And then I hung up the phone, and I called our legal department, and I said, we need to get 100 cars, and they're going to do this. They're going to change our adaptive cruise control system in order to change traffic and monitor, sort of run it right in the middle of rush hour. And then the questions just started coming. The questions I didn't think about. And it turns out, even though I work for a car company, getting cars for this purpose was a little bit harder than we thought it was going to be. And so I think the question was more of, it would be nice to have a few other departments represented from Nissan to sort of answer that question as well, although that might use a little bit more colorful language than I am here today. So, but I think what's interesting, we were talking about this before, is, we obviously figured it out. If you watch the video, we got a bunch of, Nissan Rogues on the road. I'm interested in what you guys thought if we had hung up the phone and said no, or after the first time we got told no, if we had said that's as far as we can go with it. Like, what would have happened had we not been able to do it?
Yeah, so what was that like? This came about from a research experiment that Dan and some colleagues and I did in 2016. We're on a closed track on basically a parking lot. We had one car that led around 21 rental cars and showed that we had this huge amount of fuel savings if we just changed the speed controller of one of those cars a little differently. And it was a valid scientific experiment, but it obviously was not on the real road. And so apropos of that question, what would you do if you needed to suddenly get 100 of them? Well, I did do the calculation for what would happen if I tried to just take 100 of those cars that we already had. Every car cost about $30,000 and then needed about $120,000 of sensors bolted to the top. And that was clearly a non-starter. There was no way I was going to walk into my dean's office and say, I need $12 million to buy sensors for an experiment that's going to last 1 week. So when things really started to come together was us realizing, when we spoke to Josh and the rest of his team at Nissan, we need to have access to the cars, but we don't need them forever. And you don't have to give them to us. We're going to have them for a small amount of time. We're going to make some small changes that are reversible to the vehicles. And really the magical thing was that the cars that are on the road today are all capable of doing this. How many of you drive a car right now that has adaptive cruise control on it? You have a car that's capable of wave dampening if the software changes just a little bit. And so it was with that realization that we came back and said, we think we can do this, Josh. We think we can make a change that you'll never even notice. We're going to train our crack team of graduate students to become car mechanics. And every one of those car mechanics is going to learn how to remove the trim pieces, put the right wires in the right place, be able to run those AI algorithms that come from our partners and use the onboard technology that we've invented at Vanderbilt. And then once they're able to do that, we're going to be able to put them on the road, and we're going to use the data that come off of those cars every day to make the cars drive better tomorrow. So that virtuous cycle of we send the cars out, they gather a bunch of data, our colleagues in Berkeley retrain their AI algorithms, give us the new software that night, and we run it tomorrow. And then we know that our cars are seemingly working well. But as you might have imagined, there were like 3 impossible things that Dan mentioned. We had to create the AI algorithms, which nobody knew how to do. We needed the cars, which nobody knew where we were going to get them. But then how are we going to measure what happened to the cars behind us? We can see what's happening right now around us, but what's happening behind us?
Yeah, so that was an easy question. How do you measure traffic on freeways? Well, you get a helicopter and fly it over the freeway. That's good as long as you can rent a helicopter, which you can for a day, but if you want to run a week-long experiment, that starts to get pretty expensive. You can measure traffic in the same way that people have done in the field for probably dozens of decades. You put little sensors that count the total number of cars that go over the roadway. But the really frustrating part as a scientist in this field is that we're entering this new era of AI and data-driven this, that, and the other thing, but we're still so data poor in one specific area in transportation science, and that is catching these phantom traffic jams. So roughly, when you drive down the roadway and you tap on the brakes, and the driver behind you, who's doing who knows what, finally realizes you're slowing down, and they have to brake harder than you to avoid crashing into you. And the driver behind that waits a little bit and slams down on their brakes even more aggressively. This kind of ripple effect that happens in the flow creates this phantom traffic jam that seemingly has no cause, but it's due to the way that you and I drive. Right? And the problem in my field is that for 50 plus years, we've known that it should exist. These waves should be present on the freeway. And we've caught them occasionally on a video camera with a helicopter in the 1970s flying over a freeway in Ohio. But to actually measure this stuff at scale, nobody's been able to do it. And so we started talking with our friends at the Tennessee Department of Transportation. You hear this thread about proximity, having Nissan down the street in one direction and the Tennessee Department of Transportation leadership in the opposite direction. We came to them and said, hey, let's change the way that we measure traffic in a deep and meaningful way. Let us find a way to capture, let's build an MRI for traffic. We'll study how individual drivers, their specific behaviors, create or not these phantom traffic jams. And if we do this well, it's not only going to help us when we deploy 100 cars in the flow to measure their impact, to see if we can smooth out some of those jams, but it might also open up all kinds of other innovation in traffic simulation and traffic operations for the DOT. So we really started thinking deeply about this, and then the Tennessee Department of Transportation came through as a just absolutely fantastic partner and allowed us to put up 294 4K resolution video cameras and run computer vision algorithms to process all that data anonymously so we could make this MRI for traffic. That spawned a dozen new innovation projects that was possible only because we said, hey, we're going to build this thing, and we need to happen now because Josh is going to land 100 cars on our driveway, and it's only valid for a month. So whatever the delays in the construction schedule are, I don't want to hear about it unless you want to buy me another 100 cars. And it just got everybody on board to do something that would have been absolutely impossible if it weren't for the collaborations with our partners in academia, in Nissan in particular, in industry, and the Tennessee Department of Transportation. So maybe building a little bit on that, Josh, do you want to share a few words about why you still pick up the phone when we call with other crazy ideas about what we want to do in traffic?
Yeah, absolutely. Well, one, I like hanging out with you guys. We've done this a couple of times now, and it's a lot of fun. But the other part of it is what has been happening in sort of the automotive industry is we've really moved from a recognition that we sell really amazing products to customers and really recognize that our real core business is moving people from A to B. And so how do we think about making those journeys better? And so you start to think about things like improving safety, but improving convenience, improving technology and entertainment and all these other things on board. But you also recognize that we sit inside of a broader ecosystem. You can't look at the video that we showed and not recognize that traffic was a whole bunch of cars. That is the sort of impact or part of the impact of our business. So how do we think about not only our customer journeys and making those as delightful and interesting as possible, leveraging things like new versions of autonomous technology, sort of deploying those at scale, making those increasingly better, but also how do we fit into this broader system? So when you call and you say, hey, we're thinking about this, we recognize that there are certain things that we can't necessarily do or haven't necessarily thought about on our own, and it really does require sort of that opportunity to work with the academy, to work with researchers at a sort of speed, but also the safety net that working with other partners like the Tennessee Department of Transportation and others that come in and say, look, we're going to build a test bed for you to sort of build these better products, better services, but we're going to do it at a scale that is not just Nissan. It's not just 5 to 10% of the cars on the road. It really is about improving sort of everyone, thinking through large systemic change that will ripple down to our customers at the end of the day. And we can be a leader and at the forefront of that. And that's exciting for us to be able to do. And so I think it's the opportunity both to innovate in collaboration, to go faster, to do it with sort of a safety net, but also because we know it meets our overall mission of improving sort of lives, right? And making lives better both for us, every current Nissan and Infiniti customer, but every other potential future Nissan and Infiniti customer, which we're really excited about. But at that point, I think I'm interested in sort of saying, like, where else are we kind of seeing those improvements? Where else, Jonathan, do you see an opportunity to work with a company like Nissan to work in sort of this advanced levels of technology on board of a vehicle with us and other partners?
Yeah, what excites me, is to make traffic better for everyone, to make it safer for everyone, to decrease the amount of fuel that you use, to save the stress of the drivers behind the wheel. And you can't do that unless you have a meaningful partner in the industry. I could make up all the papers I want to with simulation, and people are going to read them and say, that's great, that's a great simulation. But it's not really going to transition to a deployment. By working with y'all, we can say, we have an idea, we think this is going to work. And you can say, that sounds very interesting. Let's work together on that. And it's that working together part that's transformational. Because if you know that you need it to deploy and you need it to be on a car, you're going to make different design decisions that are going to lead to different discoveries. And so the partnership is key. And we have one of these partnerships that was just signed earlier in the year with a National Science Foundation to transition some of the safety work that we did for the 100-car test to turn those into algorithms that could run first on Nissan cars, and then if it works, on everybody's car. It could be licensed to anybody that has an adaptive cruise controller that's willing to listen to the environment around them and get a speed recommendation. And when I mentioned before, every one of you has a car that could dampen traffic waves. It's true, but they don't dampen traffic waves right now. Right now, at best, they're neutral, and they may actually be worse than neutral when it comes to making traffic better, which is something that Dan learned earlier. And so how do we make that better without just the benefit of one car company adopting it, is to have infrastructure-based decisions that are sent to all the drivers everywhere. And that's something that also, you talk about the importance of place, that's leadership that's also happening in the Middle Tennessee area, also on the variable speed limit system on I-24, which I know Dan knows a lot about.
Yeah, so building on this sort of virtuous cycle, if we could convince Nissan to let us deploy AI driver assist systems on their vehicles and then give them to total strangers on the street, then it doesn't seem that crazy any longer to take AI algorithms and apply it to infrastructure systems. We recently deployed a new variable speed limit control system that essentially tries to give drivers messages about what speed to drive to avoid creating this accordion or phantom traffic jam effect on the flow. And to do this, it depends heavily on how much drivers comply. And AI turns out to be a good approach to do this across a wide range of different driving styles, which we have here in Tennessee. So basically what we've done is about 50 days ago, we deployed a multi-agent reinforcement learning control system that dynamically looks at the data in the freeway every 30 seconds and makes a decision about what speeds to post along the freeway. It's made on the order of like 10 million decisions, all data-driven, over the last 50 days, and impact the flow of about 8 million trips on that freeway. So this partnership has just been an absolute springboard to allow us to build other really strategic partnerships with the Tennessee Department of Transportation. We're taking the same ideas and scaling them to other areas but inside the state and beyond the state, and just really excited about where we can go with this partnership. So Josh, I know it's been also important for you to use the Circles project and this partnership with Vanderbilt as a springboard for other collaborations with Vanderbilt.
Yeah, absolutely. I mean, Jeremy, who everyone met earlier, our chairman, started with some of this with the chairman of the chancellor at Vanderbilt, and sort of said, why don't we work a lot more together, right? We're right down the street from each other. Why don't we build deeper engagement? This really was, in many ways, one of the first opportunities to put something on the road and sort of prove that this could happen in a way that was safe but also really impactful. And we learned a lot both internally and sort of across government, across Vanderbilt and other places. For us, it's given us the certainty and the security to be able to say we can do these things. We can build really impactful partnerships with Vanderbilt. We're currently working with other members of Vanderbilt on projects related to stuff that has nothing to do with transportation or traffic management, but has to do with sort of how do we affect urban transportation, leveraging urban transportation systems like public transportation systems in this case in Chattanooga. How do we think about executing that? How do we have the confidence to enter into these arrangements, enter into these sort of communities and make life better for people in ways that we're not necessarily used to doing? And so I think for us, it's been a valid proof point. No one really questions it as much as anymore. They know we're going to figure it out. legal and others still ask me questions like, what are you trying to do? But what has happened is that they've said, look, how can we work together to sort of be an empower of the work that we are doing, because we know that this is something that can be trusted and can be successful. And so I think it's been really valuable for us as a commercial partner in a lot of these to say, this isn't the first and it certainly won't be the last. And so, yeah, I'm interested in what you guys think as far as how this goes forward and where are we in the last 6 seconds. Yeah, what parting wisdom?
My parting wisdom is that it's the partnership that matters. I'm not going with my hand out and asking. I'm coming with an idea and saying, let's do this together. And that's a unique thing that I feel empowered to do within this partnership, which I'm really excited about. Dan, last word?
Just an opportunity to thank the leadership at Vanderbilt and the leadership at Nissan. There were a lot of things that could have said no, and folks said, no, but try this instead. And for that, we're really grateful. Otherwise, this project would have never been successful.
And the leadership of TDOT.
And the leadership of TDOT as well. Thank you, Josh.
Cool.
Thank y'all.
Thank you.